Integration. Integration is one of the important prerequisites for engineering mathematics. Instead of saying prerequisites, we can say that it is indirectly part of engineering mathematics syllabus for GATE examination, because almost in all the concepts we require integration. Okay, so instead of doing it as a review, of course we do review only, we try to understand little more detail. Okay, so let us understand the quick review for integration. Okay, so first of all, integration is inverse process of differentiation. For example, if you are having a capital Fx whose derivative is small fx, then integral of small fx would be capital Fx. Because derivative of fx is small fx, then derivative of fx plus c is also small fx. Therefore, integral of fx dx is not just capital Fx plus c also we write it. See, for capital Fx, small fx becomes derivative, and for small fx, this capital Fx or capital Fx plus c becomes antiderivative. So here actually we are finding that antiderivative. Okay. For example, let us take the basic rules only to understand the basic rules. For example, if you are having, say, e power ax, what is derivative of e power ax? It is a into e power ax. Therefore, integral of a into e power ax dx would be e power ax. And we write the constant of integration always, because whether derivative of this or derivative of this plus c is also same, because of that we use it. But if you want only integral of e power ax dx, this a is extra now, so we divide it by a. Sorry, a. And this c by a, that is just a constant. C by a, c, they're all constant. You can put some other constant. You can initially call it as c1, then c1 by a is some other constant. So this is the idea. Okay. So what actually happens is, when you do integration and we have a linear term with a coefficient a, you have to divide by this. See, when you differentiate it, the linear term coefficient is multiplied. In integration, the linear term coefficient would be divided. Please remember this. Okay. Now similarly, if you are having integral of a power x dx, derivative of a power x is a power x into log a. Here it is a power x by log a plus. Okay. And one more important integral is constant. Integral of a dx, which is ax plus c. Because linear term, when you differentiate, you get constant. So constant term, when you integrate it, you are going to get ax plus c. Is the idea clear? And the most important one is integral of x power n dx. This would be x power n plus 1 by n plus 1. Of course, n should not be minus 1. N should not be minus 1. So let us quickly see the basic integrations. Of course, we also have the most important one. Log x derivative. What is log x derivative? Log x derivative is 1 by x. Therefore, 1 by x integral is log x. See, when you write log x, we generally write mod x, because log is defined only for positive values. See, when it is understood, we ignore this. Okay, so that's why we generally write only log x. Actually, ln x means log x to the base e. And in this course, unless or otherwise we explicitly mention, log x means log x to the base e only. So that's why sometimes instead of writing ln x seriously, we write like this also. It is only convenient notation. There is nothing to worry about it. Is it clear? Now let us see the basic rules quickly. So these are the basic rule. Integral a dx is ax plus c. Integral x power n is x power n plus 1 by n plus 1 plus c. N should not be minus 1. Integral e power ax is e power ax by a plus c. And integral a power x dx is a power x by log a plus c. And 1 by x integral is log x plus c. Now the important trigonometric functions integrals. Now, like integral sin x dx. See, we need to see what is the function whose derivative is sin x. Cos x derivative is minus sin x. There is a minus sign. That minus sign comes here. Minus cos x plus c. Now what about the next one? Cos x integral. What is integral of cos x? Integral of cos x would be sin x, because sin x derivative is cos x. That one is this. Okay. The remaining four are not that direct because integral of cosecant, secant are not directly like cosecant is secant, is not like that, right? So we have different formulae. For example, integral of tan x is secant x square, that is secant square x, secant square x. So secant square x integral would be tan x plus c. Similarly, integral of cot x is derivative of cot x is minus cosecant square x. Therefore, cosecant square x dx integral would be minus cot x. Next, derivative of secant x is secant x tan x. Therefore, integral of secant x tan x is secant x plus c. Next, derivative of cosecant x. See, cosecant people write CSC or COSEC, like that also you can write. So both the notations I am using. I generally use this notation, but in books mostly they use CSC notation. Okay, cosecant x derivative is minus cosecant x cot x. Therefore, integral of cosecant x cot x would be minus. So that minus, whenever you have, that goes for integral plus c. So these are the standard integrals when you see in the reverse direction. But what are missing here? The missing fellows are like, what is integral of tan x dx? Okay, you may remove the numbers because generally you want to see these numbers together. Okay, so let us see 6 plus 7, 8, 9, 10. Let us make this 10. Okay, tan x you want and integral cot x you want. But these are not straightforward. Let us try to understand how can you get this tan x integral and cot x integral. Okay, let us see this. We have a beautiful rule. So we'll discuss this rule once again, but here quickly we'll see this. The rule is integral f dash x by fx dx is log of fx. See, the idea is very simple, sir. When you put fx is equal to t in this, f dash x dx becomes dt. That means this problem integral f dash x by fx dx becomes dt by t, which is nothing but log t plus c. Okay, what is t here? Fx. So that is exactly what happened here. That is a secret behind this. Okay, plus c will be there for indefinite integration. Always try to put that plus c for indefinite integration. Okay, now if you see the third one, tan x, integral tan x dx. What is tan x? Sin x by cos x dx. Cos x derivative is minus sin x. So what I do is I write it as minus of minus sin x by cos x dx. Now see, derivative of denominator is numerator, that is minus log cos x, which is nothing but log cos x power minus 1, which is nothing but 1 by cos x, that is log secant x plus constant of integration. So because of that, integral of tan x would be log secant x. See, strictly speaking, you have to put mod sign, but as I told you, we try to see the values of x are such that it is positive only. So that's why we generally ignore that particular. It is only a convenient notation, nothing more than that. Similarly, integral of cot x dx, which is nothing but integral cos x by sin x dx. So what is it? Derivative of sin x is cos x, therefore it is log sin x. plus c. Okay, let us see the next two also. What about integral secant x dx? See, for this what I do is I multiply and divide by secant x plus tan x. Hope you understand the manipulation. If you expand it, you get secant square x plus secant x tan x. But I just write it like this: secant x tan x. First I write this secant x plus tan x, then I write secant into secant, that is secant square x upon secant x plus tan x. Now you see the denominator, secant x derivative is secant x tan x derivative is secant square x. That is, derivative of denominator is numerator. So the answer is log of secant x plus tan x plus c. Same is the case for integral cosecant x. Multiply and divide by cosecant x minus cot x. Cosecant x minus cot x dx. So now what we do? Denominator let it be like this: cosecant x minus cot x. Now you can write it as cosecant into cosecant, that is cosecant square x. But here cosecant into cot is minus cosecant x cot x plus cosecant square x. See, I am just writing in the order. For denominator matching, I am writing that way. Now cosecant x derivative is minus cosecant x cot x. Minus cot x derivative is, because cot x derivative is minus cosecant square x. So minus of minus plus cosecant square you are going to get. So derivative of this fellow is this and derivative of this fellow is this, which is log of cosecant x minus cot x. So these are the integrals for the standard functions. So which is we complete this log of sin x for this, and integral of secant x dx would be log of secant x plus tan x plus c, and integral of cosecant, you want to write CSC, you can write CSC cosecant x dx, which is log cosecant x minus cot x plus c. Actually there is an alternative result also for this. I try to explain with universal substitution method, okay, little later. Let me show you the results now. This particular results I'll show you later with universal substitution technique. Very simple result, okay, because integral of secant x can also be written like this, that if you want to understand, you have to know this tan x by 2 is equal to t substitution. With that, sin x becomes 2t by 1 plus t square, and cos x becomes 1 minus t square by 1 plus t square, and dx becomes 2 by 1 plus t square into dt. With that substitution you will get this, okay. So these are the basic rules. Now the third set of basic rules. So tan inverse derivative, sin inverse derivative, and secant inverse derivative, if you know, you will understand. Like basic tan inverse derivative, right? What is tan inverse derivative? Tan inverse x derivative 1 by 1 plus x square. But here you have tan inverse 1 by a square plus x square. So first of all you have to convert into that particular x by a form. So because of that, what happens when you have this particular, okay, integral 1 by a square plus x square dx, first of all you have to convert this 1 by a square, you have to take it outside, so that it becomes 1 plus x by a whole square into dx. Then you have to make substitution x by a equal to some t, okay, then dx equal to a dt. Then it becomes 1 by a square integral 1 by 1 plus t square into dx becomes a dt. That is a dt. So this a cancels, so you get 1 by a integral 1 by 1 plus t square dt. So 1 by 1 plus t square means tan inverse t derivative. Therefore integral of 1 by 1 plus t square is tan inverse t, which is tan inverse t. But what is t? X by a. Okay, sorry, it is 1 by a, no? 1 by a into tan inverse x by a. Like that you get it. But at least standard fellows, if you remember, it is good for health. So integral 1 by a square plus x square dx is 1 by a tan inverse x by a. Similarly, integral 1 by a square minus x square dx is, here we will not have that 1 by a factor. You can check with the same method, that is sin inverse x by a, you get it. Or you can also write it as minus cos inverse x by a also. Okay. And integral dx by x minus root x square minus a square means here also you get this 1 by a factor extra, 1 by a into secant inverse x by a. See, the basic rules are, for sin inverse x derivative what? Sin inverse x is 1 by root 1 minus x square. And for secant inverse x, derivative is 1 by x root x square minus 1. So that x by a factor you put it, accordingly you get the other result. Okay. That is the idea. So from these three basic derivatives you will get it. See, these rules which I given are the minimum one should know. This is the minimum. Okay, actually with these rules most of the other problems can be handled. If you want to know all other rules, you can practice it. There is nothing wrong. But minimum set of rules are these. One should know minimum these many rules. Okay, to continue further. Am I clear? If you can know at least this many rules which I given here, you can easily continue with your integrations. Of course, the other rules, whatever comes, we just practice and we'll continue. Okay, that is the idea. Let us solve few simple examples. What is this integral x square by x square plus 1 dx? See, the idea is very simple. You have to convert into some known form, then you can integrate quickly. So what I do is, I just add 1 and subtract 1. The idea is simple. Denominator I am having that x square plus 1. Numerator also I am trying to get the same thing. So what happens? This is x square plus 1 by x square plus 1 dx minus integral 1 by x square plus 1 dx. Is the idea clear? Now this is integral dx minus integral 1 by 1 plus x square dx, which is nothing but integral constant is x. Okay, 1 means constant means cx, 1 means 1x. Okay, and what is integral of 1 by 1 plus x square? Tan inverse x plus constant. A very simple example. Okay, like that. Let us see next problem. The next set of problems are based on some standard formulae from your trigonometry. Okay, see, these are the three very important formulae which you need to remember in trigonometry. Sin square x plus cos square x is 1. If you divide it by cos square x, you are going to get tan square x plus 1 is equal to secant square x. If you divide it by sin square x, the first one, you are going to get 1 plus cot square x is equal to cosecant square x. These are the three very important results, okay, which we need to remember. And one more thing here is the results about sin square and cos square x. Okay, whenever it is 1 plus, okay, I'll write here, whenever it is 1 plus cos 2x, this is 2 cos square x, and when it is 1 minus cos 2x, this is 2 sin square x. See, these results we use very regularly throughout this course. Standard, very important results, we should never forget. Okay, of course, here in place of x you may have 2x, 3x, accordingly the results will change. Okay, now let us see the first problem. Because we do not have integral of tan square x directly, you have to convert into the form for which we know the integral. And you know what is tan square x? Tan square x is secant square x minus 1 dx. And what is integral of secant square x? Tan x. And integral of 1 x plus constant of integration. See, if you do not know this result, obviously it will trouble you. Okay, let us see the next problem. Sin square, but it is sin square 3x. So accordingly you have to write this result. This 2 is also missing, so 2 will go down. So this would be 1 minus cos 2 into x. See, if it is x, cos 2x. If it is 3x, 2 into 3x by 2 dx. So you can keep that 1 by 2 outside. I'll just put this line. Okay, I'll write here 1 by 2 outside. It is integral dx minus integral cos 6x dx. This is the one, which is nothing but 1 by 2 into, this is x. What is integral of cos? Sine 6x by, see, when you have linear factor, the coefficient should be divided when you do integration, plus constant of integration. Is the idea clear? Right. Next problem. Sometimes we think too much for a simple problem also. It is 1 by sine square x dx form, sine square 2x, whatever it is. Okay, so 1 by sine means cosecant square. So this is cosecant square 2x dx. And what is integral of cosecant square? Minus cot 2x by, because 2x na linear term, so divide by 2 plus, problem is done. Okay, so this is what happens. So sometimes they give you very simple problems, but we always want to use some complicated technique and we complicate the problem. I see some people do like, sine square 2x plus cos square 2x, they do it, then they simplify. See what happens. If you do like sine square 2x plus cos square 2x by sine square 2x, same thing you are going to get. It is 1 plus cot square 2x. 1 plus cot square is cosecant square 2x. So for this step you use 2-3 steps. See, by making some proper observations we can get solutions faster. It is all about knowing standard rules and learn how to reduce to that standard rules. Unless or until you know standard rules, you will not get the idea. I always see people worry about getting ideas without knowing rules. Unless or until you know standard rules, you cannot get the ideas. Please remember that. Okay, let us see the next type of problems. Now let us see the following problems. So by making some substitution, you can make these problems very simple. Let us see the problem. First problem. What you do is you put 2x plus 7 is equal to, say, t. So differentiating, the differential of this equal to differential of this. What is differential of this? 2 into dx is equal to dt. So making the substitutions, integral 2x plus 7 would be t power 5, dx is dt by 2. And it is simple to integrate now, t power 5. So 1 by 2 you keep it outside. Integral of t power 5 is t power 6 by 6. That is t power 6 by 12 plus constant of integration. But what is t? 2x plus 7. So 2x plus 7 whole power 6 by 12 plus c. But actually whenever you have such linear term, instead of doing all that stuff, directly you write 2x plus 7 whole power 6 by 6 and the coefficient you can write in the denominator. Directly you can do it. For example, integral ax plus b whole power n dx, whenever you have this, can be written as ax plus b whole power n plus 1 by n plus 1 into coefficient of this x is a. Like that you can write. Okay. Next problem. Sine root x dx by root x. Okay. So here you make the substitution root x equal to t. That means, what is root x derivative? 1 by 2 root x dx is equal to dt. So what happens to the problem? Integral sine t, because root x is t. And what is dx by root x? See here, dx by 2 root x na? So dx by root x is 2 dt. So it is 2 into dt. So 2 is a constant, keep it outside. And what is integral of sine t? Minus cos t plus c. But what is t? Root x. So it is minus 2 cos root x plus c. Simple substitution technique. Next problem. See, whenever you have such second degree polynomial or quadratic one and numerator linear one, try differentiating it and arrange the numerator term. Okay. So the idea is you put x square plus 2x minus 5 is equal to t. Okay. See, again they write a into derivative of denominator plus b and they find ab values. Instead of that, you can directly do it. There's a simple what you call shortcut technique, but this also works fine. Okay. So this is substitution. Denominator equal to t, you put substitution. So what happens? This is 2x plus 2, okay, into dx is equal to dt. Got it? Hope you understand. Now this is nothing but 2 into x plus 1 dx is equal to dt. Now, so what is x plus 1 dx? Dt by 2. Just make this substitution in the numerator. X plus 1 dx is dt by 2. So 1 by 2 outside, and denominator x square plus 2x minus 5 is t. And what is integral of 1 by t? Log t by 2 plus constant of integration. But what is t? X square plus 2x minus 5 whole divided by 2 plus c. Simple. The next problem. And don't always do like 1 plus x power 4 is t. Okay, you will get some other nonsense. Make substitutions which makes the problem into a form for which you know the integral. So here the best substitution is x square is t. Then what happens? 2x dx. Differential of x square is 2x into dx is equal to dt. That means x dx is equal to dt by 2. So what happens? X dx is dt by 2. 2 constant, na? You put outside. And it is 1 plus x power 4 can be written as x square whole square. X square is t, therefore it is t square. You would have understood why I had done that substitution, because I know integral of 1 by 1 plus t square is tan inverse t. So that is the idea. See, it's not blindly making substitution. With that substitution, what happens? Are you going to get a standard form for which I know the integral? This is the basic idea. Okay. If you don't know the standard form, to what form you reduce it? See, people always tell me, sir, I am not able to get this particular rule. My dear friends, if you want to get that particular rule, at least basic rules we should know. And I not given 1000 rules. I just given 10 to 12 rules, which anyone can remember. Am I clear? And practice them properly. See, for example, people also do the mistake. For example, this rule is there, 1 by a square plus x square dx. What is the rule? 1 by a tan inverse x by a plus c. You know how they practice? Like this only they practice. Instead of a square, if I give 2, they cannot do it. Because they say a square should be there. 2 means what? Root 2 whole square you can write. 2 you can write it as root 2 whole square. So what happens? This should become root 2 and this should become root 2. See, this no one can give you this particular methods. You need to practice the rules with numbers. Am I clear? For this, there is no book, no method, no technique. You need to understand the rule, apply the rule. Mathematics is about how you apply the rules. That is called skill. And that skill will be developed when you know the rule, apply the rule. After applying the rule, again you come back to the rule. See, there is a circular process happening. Okay? Please see that. Now this is 1 by 2 tan inverse. What is integral of 1 by 1 plus t square? Tan inverse t. But what is t? What is t? X square. Like that. See, when you see the problem, you should see what substitution reduces to the standard form which you know. If you don't get any of the forms, then you need to think about some alternative techniques. Okay, there are any other technique like, you know, integration by parts or any other techniques. Okay, any other substitutions you need to think about. Is it clear? See, I am going to give you some very standard techniques. it would be sufficient for our examination. If you are preparing for JEE examination or different examination, I cannot help you, because this class which I am going to take is for a particular examination in mind. If you are preparing for basic engineering mathematics for your university examination, or if you are preparing for GATE examination, these ideas are sufficient. See, I am not saying that this is it. If you can able to use it, that is enough. Am I clear? See, no one can give you this particular type of problem. Suppose 1 by 3, again I cannot give you the problem. I can only give you the rule and I can tell you different ideas. So whenever you see a new problem, either you should know a rule or you should know how to reduce it to a rule. Okay, these two things automatically comes when you know standard rules, you practice them and you can able to apply them. Am I clear? See, this particular topic is purely analytical, problem based. It is problem solving skill. Okay, you can develop this properly if you know the rules. See, practice the rules regularly. You go to the rules regularly. See, when I say practice rules, people say 1 hour, 2 hours practice. No, it's not like that. 1 minute, 2 minutes practice. You need to just revise in your mind what are the rules. Okay, what is integral of 1 by a square plus x square dx? Okay, 1 by a tan inverse x by a. So automatically it comes. You don't have to do separate work for that. Okay, while doing some activity, you can just think about, okay, what is happening. So instead of a, if I put 2, what happens? So just think about some numbers and apply for that. That application will automatically help you to remember the rule. Unless or until you remember the rule, you can't solve the problems. Okay, like that. Let us see the next problem. Integral x into root x plus 1 dx. See, this x plus 1 whole power half it would be. If you use binomial expansion, it will be your lifetime achievement. So for this, whatever is under that root, that should be like a single variable. The outside fellow without root can be some factor or some linear term plus 1, like that it can be. So what I do is I make this x plus 1 is equal to t. Then x will be t minus 1. That is, outside factor is like t minus 1 factor. Inside factor is now t. That is the basic idea. Now what happens to dx? dt. Now it is integral x means t minus 1 and it is root x means root t dt. So this is integral t minus 1 t power half dt. That is nothing but integral t power 3 by 2 dt minus integral t power half dt. It is regular integration. T power 3 by 2 integral is t power 3 by 2 plus 1 by 3 by 2 plus 1 minus, this is t power half plus 1 by half plus 1 plus c. That is all simplification. Now it is, 5 by 2 na, 3 by 2 plus 1 is 5 by 2, that becomes 2 by 5 t power 5 by 2, and it is 3 by 2, that is 2 by 3 it becomes, this minus sign, sorry, 2 by 3 t power 3 by 2 plus c. But what is t? X plus 1. So it is 2 by 5 x plus 1 whole power 5 by 2 minus 2 by 3 x plus 1 whole power 3 by 2. See, I am just using the basic rules and simple substitutions, nothing more than that. And my dear friends, it would be sufficient. If you can able to properly understand the rules, understand the ideas, that is sufficient for any examination. Okay, only thing is you should be brave enough to apply the rule. Okay, most of the people, they just read the problem like this. If you read, nothing is going to come. Mathematics you should always solve. Okay, put pen on the paper, try. Okay, so while trying it, all the rules should play in your mind. Am I clear? Like that. Let us take next problem. Here it's like 1 by 1 plus e power x. What we can do is take e power x common, so that it becomes e power minus x plus 1 dx. Now this is e power minus x by e power minus x plus 1 dx. Now you put e power minus x plus 1 is equal to t. Now derivative of denominator becomes numerator. What is derivative of this? Minus e power minus x dx. is equal to dt. So e power minus x dx would be minus dt. So what happens? This would be integral minus dt by t, which is nothing but minus log t plus c. What is t? 1 plus e power minus x plus c. That is the idea. Okay. See, it's all about reducing it to the form for which you know already integration. Okay. Now let us see integration of some rational functions. Integration of rational functions. See, the idea is using partial fractions how to solve the problems. Okay. So let us take one simple example. Integral, say 2x minus 5 by x minus 2 into say x minus 4 dx. So you divide into partial fractions, automatically integral 1 by x form you are going to get. Integral 1 by x is log x dx, log x plus c. That would be the answer. So for this partial fraction, what is the idea? A by x minus 2 dx plus or minus, we do not know, that we will put on a hold. Let us put plus, we can change later. X minus 4 dx. Okay. So we need to find the values of a and b. Okay. So for a, what we need to do, you close x minus 2, put x equal to 2 in the remaining part. So 2 2 is 4 minus 5 minus 1, 2 minus 4 minus 2. That is 1 by 2 is a value. So a value is 1 by 2. You can write 1 by 2, 2 outside also you can write 1 by 2 like this, constant na? You can write like this. Now for b, you have to close x minus 4. Close x minus 4, in the remaining part put x equal to 4. So you get b value. So 2 4s 8, 8 minus 5 is 3 and 4 minus 2 is 2, that is 3 by 2. Plus only, so it is plus 3 by 2. So you can write 3, 1 by 2 outside, or you can write complete 3 by 2 outside also. It's just a constant, right? It will not trouble you. 3 by 2. You can just write 1 here. Now it is integral 1 by x minus 2. See, when it is x minus 2 or x does not matter, answer would be log of that, log of x minus 2. And it is 3 by 2 log of x minus 4 and constant of integration. Is the idea clear? Like that. Now you can, if you want, you can write like x log of x minus 2 whole power half plus log of x minus 4 whole power 3 by 2 plus. That is further simplification. If you want, you can do it. Log a plus log b is log ab. That also you can write it. Log x minus 2 whole power half x minus 4 whole power 3 by 2 plus. It depends on, see, the final form depends on the answer which they give. Okay. So this is the simple idea. Okay. Let us take one more example. Integral 2x plus 3 by x plus 1 into x square plus 1 dx. Because x square plus 1 here is irreducible polynomial. Okay. So for this, the idea is a by x plus 1 dx plus this one can be written as, for this we write bx plus c. For this quadratic irreducible fellow, we write bx plus c in the numerator. We need to find b and c values. X square plus 1 dx. So this is how we need to divide into partial fractions. Finding a is very simple. You close this x plus 1 part. In the remaining part, put x equal to minus 1. So if you put x equal to minus 1, minus 2 plus 3, that is 1, and minus 1 square is plus 1. 1 by 1 plus 1 is 2. So a value is ready, 1 by 2. But for b value, you need to do the cross multiplication and verify. See, this is how we get 2x plus 3 on left side. On right side, it is a into x square plus 1 plus bx plus c into x plus 1. So you need to find ab values. Just put some random values of x other than minus 1. Then you can get some relations, solving which we can get bc values. Okay. Because bc are missing. A already known, no? You can write a is equal to 1 by 2. Now let us put x equal to 0 in this. we get some relation 3, because 2 into 0 is 0, 3, this is 0, so it is 1 by 2, this is 0, so C into 1, C. So that means C is equal to 3 minus half, 2 and half, or 5 by 2. Now you got C value also. Now you put some other value, say x equal to 1. Okay. So what happens when you put x equal to 1? It is 2 plus 3, 5, half, 1 plus 1 is 2, plus b, x is half, 1, x is 1, so b into 1, c is 5 by 2. And x is 1, 1 into 1, 1 plus 1, 2. So this is 1, this is 5, so it is 2b plus 5, that is 6. And if when 6 goes to the other side, minus 6, 5 minus 6 is minus 1. So the value of b is minus half. So the work would be solving this, substituting and solving that problem. So now how can you write it? Integral a means 1 by 2. So it is 1 by 2 into 1 by x plus 1 dx. This part is ready. But this part you have to work. B is minus half, C is 5 by 2. So it is minus half x plus 5 by 2 by x square plus 1 dx. Okay. So this is the idea. Now you need to integrate. This is direct log integral, but this one, derivative of denominator should be numerator. We have to arrange things in that manner. Okay. So how can you arrange it? Integral 1 by, okay, shall I write the answer for this? So what is the answer for this? Log of denominator. This one we need to solve. Okay. So you put x square plus 1 is equal to t in this. Okay. So what happens? 2x dx would be dt. So here we can divide into two parts actually. One part would be like, first part would be like integral minus half into x by x square plus 1, and the other part would be 5 by 2 into ds, don't worry, don't forget, 5 by 2 integral dx by x square plus 1. Okay. So this is the substitution only for this part. Okay, let me write below this. For this you put x square plus 1 is equal to t, that is 2x dx is equal to dt. And this is direct integral of 1 by 1 plus x square. You know the answer for that. So what is the answer? 1 by 2 log x plus 1 minus half into, see, x dx is dt. So x dx is dt by 2. So you are going to get integral dt by 2. 2 2's 4 you get here by t. And this is 5 by 2. What is integral of 1 by 1 plus x square? Tan inverse x. So this would be 1 by 2 log x plus 1 minus 1 by 4 log t plus 5 by 2 tan inverse x and plus c. But what is t? T is nothing but x square plus 1. 1 by 2 log x plus 1 minus 1 by 4 log x square plus 1 plus 5 by 2 tan inverse x. Okay. See, in GATE such lengthy kind of questions, generally they will not ask, some logical type of things only they generally ask. Okay, anyhow you can solve it. It's not difficult. You know, lot of mechanical work is involved. Am I clear? That is the idea. See, for this we need to know partial fractions. So I had done a separate video on partial fractions. Please go through that. Am I clear? To get the idea how you reduce it to partial fractions. If you know it, rest of the story is simple simplification. Am I clear? So I generally consider these problems as, you know, just mechanical work. After that, there is nothing in this. We are just substituting and getting the answer. Got it? So this is about handling rational functions. Let us understand this universal substitution. The basic idea is you make the substitution like tan x by 2 is equal to t. With this substitution, the sin x fellow, that is wherever sin x is there, that can be replaced by 2t by 1 plus t square, and cos x can be replaced by 1 minus t square by 1 plus t square, and dx is replaced by 2 dt by 1 plus t square. See, the basic idea is very simple, sir, because sin x means 2 sin x by 2 cos x by 2. What I do is I divide by cos. People don't accept, so I also multiply by cos. That is, it becomes cos square x by 2. And this is 2 tan x by 2. Cos square can be written as 1 by secant square. So this is what going to happen. And this is 2 tan x by 2. And secant square is nothing but 1 plus tan square x by 2. But what is the substitution you put? Tan x by 2 is equal to t, that is 2t by 1 plus t square. So similarly, cos x also can be shown in the same manner by taking cos x means cos square x by 2 minus sin square x by 2. You can get this. That is the basic idea. Even here, if you differentiate it, you can get this particular value also. See, generally this universal substitution is used whenever you have rational function of sin x and cos x involved. Using this substitution, it can be converted to rational functions. Means you can solve it by partial fractions. But the problem is this will create some complicated calculations sometimes. So some other alternatives also people check. What I do is I use this universal substitution for solving our basic problems. Okay. Integral secant x dx. Okay. So what is integral secant x? 1 by cos x dx. So make our universal substitution. Put tan x by 2 is equal to t. So when you put this substitution, you should remember all this. Sin x becomes 2t by 1 plus t square, cos x becomes 1 minus t square by 1 plus t square, and dx becomes 2 dt by 1 plus t square. So if you remember directly, you can substitute. Otherwise, you have to waste your time again deriving them. Okay. See, whenever you want to use such rules, you should remember them. You can't say, no, I want to derive it and check. Derivations is only for our understanding purpose. In competitive examination, you can't derive every rule and use. Okay. Remember that. So it is 1 by, what is cos x? 1 minus t square by 1 plus t square. And what is dx? 2 dt by 1 plus t square. These two get cancelled. So this is 2 by 1 minus t square dt. And here you have to use partial fractions. If you directly know 1 by a square minus t square formula, you can use it. Otherwise, you have to go for partial fractions. So 2 you take common. 1 minus t dt plus integral 1 plus t dt. So we know partial fraction technique, use it. Close 1 minus t and see, it's like, integral 2 by 1 minus t into 1 plus t dt, right? So if you want to know the power of this 1 minus t, close 1 minus t part. In the remaining part, put t is equal to 1. So if you put t is equal to 1, 1 plus 1, 2, 2 by 2. That is 1. Okay, you can remove this particular 2 because we are using the 2 also here, right? So it is simply 1. Similarly for this 1 plus t numerator, if you want, close 1 plus t. In the remaining part, put t is equal to minus 1. So t is minus 1 means 1 minus of minus plus 1. That is 2 by 2, 1. So directly you got it. And what is the integral of this 1 by 1 minus t? See, it is log of 1 minus t, but coefficient of t is minus 1, you have to divide by minus 1. And this is simply log 1 plus t plus constant of integration. And this is nothing but log 1 minus, or you can say minus log 1 minus t, minus log 1 minus t. And this is log 1 plus t plus c. Okay. Now what happens? Log a minus log b is log a by b. So you are going to get log 1 plus t by 1 minus t plus c. Log 1 plus t by 1 minus t plus c. Okay. And that is nothing but, what is t? Tan x by 2, 1 minus tan x by 2 plus c. This can be written as log of tan pi by 4 plus tan x by 2 by 1 minus tan pi by 4 into tan x by 2. So now this is log of tan a plus tan b by 1 minus tan a tan b is tan a plus b, and that is the answer. Okay, this is how we get that particular answer. You can try the same idea for integral cosecant x dx also. Let us see the next problem. Here also 1 by 1 plus sin x plus cos x. So the idea is put tan x by 2 is equal to t. So what it will do? It will convert sin x to 2t by 1 plus t square. Cos x is converted to 1 minus t square by 1 plus t square, and dx is converted to 2 dt by 1 plus t square. See, here I am writing, you should remember all this. Then only you can use such procedures. Am I clear? Now let us see the integral. This 1 by, making this substitution, what happens to the integral? Make all these changes. 1 by, the integral changes to 1 by 1 plus, what is sin x? 2t by 1 plus t square. What is cos x? 1 minus t square by 1 plus t square. And what happens to dx? 2 dt by 1 plus t square. So this can be written as, now you can write, see here denominator you can take 1 plus t square LCM, so that it becomes 1 plus t square 2t plus 1 minus t square, and this is 2 dt by 1 plus t square. So these two get cancelled, and now you simplify this. In this also t square minus t square get cancelled, you get 1 by 2 plus 2t 2 dt. So I can take 2 common in the numerator, in the denominator, so that it is 2 dt by 2 into 1 plus t, 2 cancel, and you get integral 1 by 1 plus t dt. So what is it? Log of 1 plus t plus c. But what is t? Tan x by 2. So substituting, you get the answer log, okay, 1 plus tan x by 2 plus c. So you are substituting back t value. T is equal to tan x by 2, you are substituting back. So this problem looks very simple, but not every time you get such beautiful result, because denominator, luckily here t square cancelled, otherwise you are going to get a quadratic one. Of course, it's not difficult, it is, lengthy work you will be having. Okay. Sometimes to avoid such things, instead of using universal substitution, we use some other substitution techniques. Let us see that. Now see this particular problem, integral 1 by 1 plus sin x. Of course, here also you can use the same technique, but what I do is, instead of using that universal substitution, I multiply and divide by 1 minus sin x. So multiplying and divide by 1 minus sin x. So what happens? It is integral 1 minus sin x by, and what is 1 plus sin x into 1 minus sin x? 1 minus sin square x dx. And that is 1 minus sin x by, what is 1 minus sin square x there? Cos square x dx. Now this is 1 by cos square x, separate you can write now, 1 by cos square x dx minus integral sin x by cos square x dx. 1 by cos square is nothing but secant square x. And this one, what I do is, sin x by cos x can be written as tan x, and there is 1 by cos x is remaining. 1 by cos x is secant x dx. And now you know integral of secant square x is tan x, minus integral of secant x tan x is secant x plus. See, this problem can also be solved using universal substitution, but it will make it complicated. See, it's all about identifying the right approach, and also it depends sometimes on your options. Okay, based on that also you can think about it. Is the idea clear? Let us take one more problem. Now let us see the next problem. Of course, this problem also can be solved by using universal substitution. It will make it complicated. See, sometimes this universal substitution can make it complicated, sometimes make it simple also. Okay, it depends on the problem. But whenever it is 1 by a sin x plus b cos x, you can also remember it as a formula. For that, I'll tell you a trick. Please see here. We make a substitution. A is equal to r cos theta and b is equal to r sin theta. It's actually polar coordinate idea, we call it. So what happens when you make this substitution? Okay, so the value of r would be under root a square plus b square, because when you square it on both sides, then you will understand, because cos square theta plus sin square theta is 1 and theta value will be tan inverse b by a. So this helps you in solving this problem very faster, and you can also remember it as a formula. So what is it? 1 by, so r cos theta sin x plus r sin theta cos x dx. So this 1 by r, if you take common, it is cos theta sin x plus sin theta cos x. Sin a cos b, cos a sin b. That can be written as sin a plus b formula. Sin x plus theta d theta. And which is nothing but cosecant x plus theta d theta. And what is integral of cosecant, sir? Cosecant is log tan x by 2 plus, okay, x means this one, x plus theta by 2 plus. Now what is r? Under root, r is under root a square plus b square, log tan, you can write it as x by 2 plus theta by 2. So 1 by 2, what is theta? Tan inverse b by a. See, in your plus 2 level you can remember it as a formula, but at this level remembering it as a formula is useless. See why I given this particular problem? We have so many rules like that. If you go on doing all that, you need to do your plus 2 again, prepare for JEE and start your gate examination preparation, which is not possible. Okay, so they just expect you to know standard rules which are useful at this level. It is called review. Okay, see, I try to give some basic ideas here for integration. Now we start with the important parts like integration by parts, and one more rule called DI rule, also known as Leibniz rule, and some important formulae we discuss. Okay, let us see them now.